Okay, so we got the same thing. It's a little bit. I wrote a little bit smaller so I can leave myself a little bit of room, right? So what we're going to do is, again, try to solve this equation, and we're going to solve this equation by cross multiplying this guy up here and that guy up there. Okay. So what we're going to do is grab this guy, kick it up. So 5 times 6x is going to be 30x is equal to 3x times 3x plus 1. So this guy comes up and multiplies both that term and that term. So this is going to be 9x squared plus 3x. Okay. Now, again, I should have followed my own advice. Before we continue with this, before we start moving things around, we should have written down a restriction here. And a restriction is 3x cannot equal 0, and 6x cannot equal 0. Both of them state, basically, give us the result that x cannot equal 0. X cannot equal 0. Now keep that there, because when you write your final answer, you have to include that in your final answer. So over here, we're back over here. What we want to do is bring all the x's to one side. Now what I'm going to do is I'm going to grab this guy and bring this to the other side, because I want to keep my x squared, the first term, positive. I'd rather not bring those guys over this side. I like keeping the first term in general positive. Okay? So this is going to be, now it doesn't make a difference if I write this over here and write it over here, because this side is just going to be 0, right? So I'm going to line up my equal sign. I'm going to have 9x squared plus, when 30x comes over, it becomes minus 30x. So it becomes, oops, it's not a plus. You shouldn't write it down until you solve for it, actually. Until you figure out what it is minus 27x is equal to 0. Okay. Now, we haven't talked about this, but we will talk about it later on at some point. The way we have to solve this is take out a GCF, the greatest common factor. Now the GCF out of this, basically we're factoring this right now, and there's 4 types of factoring, which is GCF, simple trinomial, complex trinomials. I think they call it complex trinomial, when you have a variable in front of the x squared. This is a quadratic equation, by the way. I'm going way beyond what we've covered so far, but this is just a sort of a pointer of how we go about doing this. Okay? And then there's the difference of squares, right? But we will talk about those later on. Now the way we're going to solve this equation is, we're going to take out a GCF here, and the GCF from this, greatest common factor, is you have a 9 here, you have a 27. If you take out a 9 from this, you got 1 left. If you take out a 9 from this, you get a 3 left. So the greatest common factor from these is 9 can come out of this. Okay. You have an x squared, which basically means you have 2 x's, you got an x there. So you can take out an x, one single x from both of them. So you got 9x coming out, right? What you got left over is, yet if you multiply 9x by x, you're going to get x squared. So x, you put x here, and you're going to put 3 over here, is equal to 0, right? Here's the property of 0, which we end up using when we're solving these types of equations. Okay. Now, with the problem of 0 is our restrictions, right? One solution, one tool that we can, or one property that comes up with 0 that we end up using is the only way to multiply 2 things or multiple things together to give you 0 is that at least one of them has to be 0. Okay. Now let's do an aside here. I'm just going to do this thing in pink because, and I'm going to talk about this a lot more later on, but this is something that, you know, it's usually not talked about, not introduced. From what I've seen, all the students that I've dealt with, is most people don't know why you separate these into 2 terms. Because what happens here is, if you have 9x times x minus 3 is equal to 0, what you do is, the solution to this is, you set each one of these equal to 0. And the theory behind this, or the basically train of thought behind this is, how could you multiply A times B times C times D to give you 0? How could you multiply 4 things to give you 0? The only way you can multiply anything together to give you 0 is that if at least one of them is 0. Now, we don't know if it's A, B, C, or D that's equal to 0, or a combination of all of them, or all of them, right? So what we do is, we set each term equal to 0. So what we're going to do is, if we get an equation like this, we're going to go a is equal to 0, b is equal to 0, c is equal to 0, and d is equal to 0. And that's how we solve these types of equations. This is the same thing. When we have two terms multiplied together to give you 0, what you do, the way you solve for this is, you set each one equal to 0. So over here, you would go 9x is equal to 0. And over here, you're going to go x minus 3 is equal to 0. And the solution to this is you just divide by 9, and 0 divided by 9 is 0. Oops. So your solution here is x is equal to 0, and your solution here is just going to be, you move the 3 over, so x is equal to 3. Now over here, we've got two solutions, right? Over here, we've got two solutions, but we really don't have two solutions because we have to look at our restriction when we set it up at the beginning of the equation, right? And our restriction said x cannot equal 0. Over here, we put x equals 0, but it can't equal 0. So when you write your final solution for this equation, you're going to eliminate this answer. X cannot equal 0. So this doesn't exist. So the only solution is x is equal to 0. Okay. Now what's going to happen is a lot of schools that I've seen, what they do is they give this type of problem and they say solve. Write it up. Let's see. They say solve and check. Okay. Whenever they give you a question like this, what they're usually going to do is say solve and check. Okay. When they say this, when you get to the final answer at the bottom over here, there's a whole bunch of work that you have to do on the side or at the bottom of it to check the answer to this. So let's do a check as well and go through the whole process of just doing one complete question with the restrictions. Right? So over here, your solution would have been x is equal to 3 and x cannot equal 0. Right? That's our final solution to this. Now, if we didn't write our restriction during the check, this would have come up. The x cannot equal 0 would have come up because the answer would have been invalid. So let's do a check for this question and see how that works out.